This presentation is based on the research article by Jenny Safran and Diana Wilson, and the paper is called From Syllables to Syntax, Multilevel Statistical Learning. So we're just going to jump right into the key terms and concepts, the most important being statistical learning, which is the tracking patterns and regularities over an input, which in this case is the speech stream, such as syllables, which is of particular interest to this study because we're looking at how infants can compute transitional probabilities. And that is the likelihood that a particular syllable will happen given what the syllable before it was. So in English, T is fairly common to follow pre because pretty is a word that belongs to English and it's a frequent word that belongs to English. We have to remember that oral speech has no spaces to indicate word boundaries. So infants use these transitional probabilities to perform word segmentation and to figure out what syllables combine into words. And from that information, they go on to perform syntax learning, which is the regularities for lexical units, those being words, in a broad context, that being sentences. The levels we're talking about are the combination of syllables into words, and then moreover, those words combining into sentences. And we want to see the mechanisms by which infants employ when they're learning to speak their first language to be able to perform these computations and understand how it is that that works in an impoverished input. Can infants apply statistical learning at these different levels from a single input? Are they doing this in steps or are they doing this simultaneously? And that is what this experiment aims to clarify and figure out. So they took 41-year-olds that spoke one language. The stimuli for the experiment was based on the finite state grammar task, also known as the Reaver task, which we'll talk about in more detail, and the procedure was the head-turn preference paradigm. So going back to the finite state grammar learning task, you take a limited number of units that can generate numerous phrases. So if you look to table 1, which is from this experiment, you have group A, group B, group C, group D, group E, and they belong in a certain order to language A and in another order to language B. So you can pull a word from each group to formulate a string of sentences, which is what was played for these infants. So a sample sentence would be dato, gobi, buto, tubi, dipa. But because it's a word segmentation task, these are all monotone. They're computer generated by a female voice. The familiarization phase involved the infants listening to 16 of these sentences repeated twice through. And so the medium by which the infants heard this stimuli was the head-turn preference paradigm. So you have the infant sitting on the parent's lap. There's a speaker on the left, a speaker on the right, a light in front with the experimenter behind viewing the experiment. And the speakers activate in response to the infant's looking behavior. So the infant looks left, that speech stream activates, same on the right. So when they had 12 trials in the test phase of 6 new sentences based on that finite state grammar and 6 ungrammatical sentence sets, they saw that there was no difference for the infant looking time between language A and language B, which is to be expected, but there were longer looking times for the grammatical sentences for more of the infants. The experimenters actually ended up repeating this experiment without group E to see if that would make the task easier and increase how many infants looked to grammatical sentences. Unfortunately, it did not. It was 25 out of 40 infants that listened longer, and if you look at the white bars on the graph, these are the longer listening times for the grammatical sentences. So what does this mean? What can we infer from these results? Well, we know that infants can indeed track more than one level of regularity. They can compute transitional probabilities for syllables. They can take the word information they now have acquired and reuse that as the input for syntax learning. The success of these babies in this experiment gives insight to the mechanisms that infants are using when they're actually acquiring real natural language. If they're able to do this from an impoverished input, just imagine how powerful the mechanisms at play are when they have prosody at their disposal and visual cues and contextual cues helping them acquire language.